Yes friends, we are continuing with the question number 6 here. So I am writing here that what is the given here. We are given the odds in favor of hitting a target, in favor of A hitting the target are 4:5, okay, and that of B hitting the target are 3:4. 3:4, right? Then to find here, so we have to find out here, to find the probability, that, and the probability of the target being hit, find the probability of the target being hit, again the same kind of situation, being hit at all, all when they both try, this is the point here. So solution. Now see here that what is the probability. Now this is the ratio given to us, 4:5. So what is the age ratio? 4/9, because sum of the ratio is in the denominator, and in favor of A it is 4, so 4/9 is the probability. So let me take here the probability. Here we are given the probability that A will hit the target, equal to what is that, 4/4 plus 5, that means 4/9. In the ratio, if it is given that is hitting target is this, that probability is given. Chances of A is hitting, chances means probability. So this is A is probability of hitting the target, 4/9. The sum of the ratio in the denominator into the ratio in favor of A, which is in the numerator, so that's 4/9, and the probability that B will hit the target, is equal to, that is for 3/4, so this is 3/7, because 3/3 plus 4. Sum of the ratio in the denominator and the value which is in favor of B, which is 3, the ratio is 3/7. So this is 3/7. This is B is hitting target. Again, now A is hitting target and B is hitting target, both are independently done. Okay. So in this case, the same kind of situation which we did in favor, but the problem is solved. So there is something common between them also. So independent, just we did the same question in the previous question. Or we can find, suppose the problem is not hit by A by B. If I find the negative of both, mean complement probability of A and of B also, and then multiply them together and subtract that value from 1, the answer will be there. Okay, so that can also be done. The two ways I am going to solve it. Okay. So the probability by addition theorem, let me apply. And by addition formula, by addition theorem, let me take by addition theorem of probability. In this case, the two events are not mutually exclusive, but they have some common parts also, inclusive also. That means that in that we can say that they are having the two events are independent. Let's suppose A is hitting, B is hitting, that is the point. So addition theorem of probability, okay, of second type for not mutually exclusive events, not mutually second case, not mutually exclusive. Because something is found, because the problem is to be solved. Okay, so that means we can find out it by solving probability of A union B is equal to, both events A and B are there, this is equal to probability of A plus probability of B minus probability of A intersection B. In this case, A and B are independent events because A hitting, B hitting, both are independent in this case. That will be probability of A into probability of B. This will give us probability of A, which is 4 upon 9, plus this is 3 upon 7, minus 4 upon 9 into 3 upon 7. Okay, because this is probability of A intersection B is probability of A into probability of B, as we did in the previous question, question number 5. Okay, so this is the similar type of problem B. So let me solve it here. Therefore, the target is being hit, the probability, hence, can say, hence, the probability that the target is being hit, the target is being hit, is equal to, so 4 upon 9 plus 3 upon 7 minus this 3 3 is 9, so 7 3 21, 4 upon 21, here it is. So finally let me solve it. So LCM is 63, 9 7 ja 63, it is 63 here. Okay, and this we will do. Let me take 63 of all. This 9 7 is 67, 4 is 28, this is 28, plus 7 9 is 63, 9 3 27, 27, minus 21 3 is 63, 3 4 is 12, this is 12, minus, so it will give us 27. Okay, so this is 50, 55, 7 plus 8 5, and 15 or 1 5, so 55 minus 12 upon 63, it is giving us 43. Yeah, 5 minus 2 is 3, and this is 43. So 43 by 63, this is the probability of the target is being hit by both A and B, or target is being hit either by A or by B or by both. That is the question here. So this is the answer. Okay, so this question is can be done in this way. This is the first type I have discussed about. Second type, let me take that. First we find that suppose the target is not hit by A by B. So the probability of A and B will be probability of A into probability of B. We multiply that. The probability of not hitting the target, let me first find out, then subtract that value from 1. So the target being hit. That probability can be calculated. So by complementing, so probability of second, let me take second way of solving this problem. Let the problem is not solved by A. Let the okay, the problem okay, not let. Second way of solving this problem. Let this problem, okay, this problem. So the problem is not solved. The problem, sorry, the target here, not problem. The target is not hit by A. The probability of that means probability of A naught is equal to, this is 1 minus 4 by, I think 4 by 9, yeah, it was 4 by 9 here, 4 upon 9. So 1 minus 4 by 9 is 5 by, this is 5 by 9, this is first part. That target is not hit by A. Negative of A is obtained by 1 minus probability of A. So 1 minus probability of A is 4 by 9. So subtract this from 1 because 4 by 9, okay, that was there. Now, and the target is not hit by B. What is the negative of B? And here, and target is not hit by B. Target is not hit by B is equal to 1 minus target is being a definite probability of B. This is 1 minus, it was here 3 by 7 here, so it is 4 by 7. Simple. 4 by 7 is probability of B naught. Probability of A naught is this 5 by 9. Let me take now the probability that the target is not hit. Target is not hit by A and B is equal to probability of A naught intersection B naught. That is probability of A naught into probability of B naught. These two are to be multiplied. This is what probability of A naught is 5 by 9 into probability of B naught is 4 by 7. What is this? Okay, 63. This is 5 4 20. So 20 upon 63. This value is there. 5 4 20. 9 7 60. So 20 upon 63. Now this is of not hitting the target, negative. Now if I subtract this from 1, that means probability of not is being hit. Hence the probability of probability of the target is being hit. The target is being hit. Okay, is equal to 1 minus probability of the target is not hit. A naught intersection B naught, which we just calculated. This is 1 minus 20 upon 63. Right one is. This is 63 minus 20, that is 43. So 43 upon 63, this is the same answer which we just calculated. So this is the second method. The two other methods can also be described easily. By that also the same answer will be obtained. Let's suppose the target is hit by A only, okay, or by A and by not by B, okay. So A is hitting the target but not by B. The probability of B is hitting target plus by B is not hitting the target, or the problem is being solved, so A will hit the target. The probability of A, let me do those two methods also. What is that? The target is being hit. The target is not hit by A but by B. But by B. That means A is not hitting. Not hitting is 5 by 9. Hitting by B is 3 upon 7, I think. Yeah. So this is this value. But the target is being hit. But target is being hit. So the probability of that will be, now first is 5 by 9, which is probability of A is hitting, A is not hitting but B is hitting, right? B is hitting is, so A is hitting we have to put separately, plus this is B is hitting but A is not hitting. What is A is hitting? A is hitting was 4 by 9 plus A is not hitting and but B is hitting, so this value is there. This is 5 15 by 63. 9 7 63. Let me take this 63. So this is 63 here LCM. Let me not cancel out this by 3 because 3 it was cancelled out by 21 times. So 63 is LCM again. 9 7 just 63. 7 4 is 28. This is 28 plus 15. 8 plus 5. 13, so this is 43 again. This is 43 by 63. Same answer has come. This is the probability of hitting, okay, by either of A. Now in this case, what we take here that A is not hitting but B is hitting. This is the probability that B is hitting, not A. But A is hitting plus B is hitting but not by A. These two, if I add them together, in this case, the inclusive part we have taken out. These two are added up, so this is the same answer. In the same way, if I take that, suppose A is hitting, B is not hitting, that plus B is hitting, if I add them, that will also give the same answer. So these are the 4 methods of solving a particular problem here in this case. Okay, so let me take now question number 7. So what is question number 7, guys? Let me just read it and then solve it. Question number 7. Now question number 7 is, let me see what is given to us. First let me change the marker here. Okay, now question number 7, what does it say? 7 says, from a pack of playing cards, one card is drawn at random, and the probability that it is either a spade or a club. Again, club is a separate kind of paper, or card in this case, card, and spade is another card. Both are mutually exclusive evens here. Both are added up. This is the first addition formula. First type of mutually exclusive evens. Okay. So for mutually exclusive evens, we say probability of A union B is equal to probability of A plus probability of B. By this same method, we can solve this problem. Let me take this, what is given to us. We are given here, so from a pack of 52 cards, we are given here from a pack of playing cards, from a pack of playing cards, from a pack of playing cards. One card is drawn at random. It says one card is drawn at random. Alright. Then to find what the probability that it is either to find here the probability that probability that it is either a spade, that it is either a spade or a club card, or a club card. Club cards are 13, spade cards are 13. So the probability of selecting spade card 13 upon 52. This is also 13 upon 52. 1.4 plus 1.4 is 2 upon 4 here. That means 1.2. Okay, that is the problem here. So spade card, a card. Let me say, take the solution here. Here, number of spade cards in total playing cards is equal to 13. Okay, is equal to 13. So this is NA. Let A is the event. Let A be the event. The card selected is a spade card. Card selected is a spade card, and B be the event that card selected is a club card. Selected is a club. Right, is a club card. That is the point. So probability of A here, the probability of A will be NA upon NS. What is this? NA is 13, total number of favorable cases 13 upon 52. This is 1 upon 4 here. And probability of B is also same type. Okay, so we have to just take that this is NB upon NS. This is also 13 by 52. This is 1.4 here. This is second part. So the card is either a spade or a, both are mutually exclusive events. Hence the probability, let me find. Hence the probability, hence the probability of the card selected is either a spade or a club card is equal to, so this is probability of A union B, which we can do is imply probability of A union B by addition theorem. This is probability of A plus probability of B, because these both are mutually exclusive events. Club cards and spade cards are totally different, nothing common between them, so they are mutually exclusive events. So this is 1.4, 1.4, 1.2, because this is 2/4, that means 1.2. So we can say 13 by 13, 26. Directly we could do 26/52, that means 1.2. This is the final probability answer. Question number 7 is also done on the basis of addition theorem. Let us take now question number 8. Let me talk about question number 8. What does question number 8 say? Let me check it first and then solve it. Yes guys, question number 8 here. What is given to us? First let me read it and then solve it. Question number 8 says a coin is tossed 4 times. 4 times. Try to understand. Right. What is the probability that all the 4 are heads? Wonderful. Okay, so we are given here a coin is tossed 4 times. 4 times. Right. To find here the probability that it is that all the 4 are heads. So the probability, we have to find the probability that all 4 are heads. Now in this case, try to understand 2 raised power 4, sorry, 2 raised power 4, because one time there are 2 possibilities, 2 outcomes, head and tail. Second time it is 2 raised power 2, means 4 cases are there, head, tail, and HT and TH. Head and tail, tail and head, and tail. Head at first probability, this is in 2 times draw. If it is thrown 4 times, if it is tossed 4 times, then 2 raised power 4, that means 16 total cases are there. Out of those total cases are 16 undoubtedly, but we have to just find that what the probability that in first draw it is a head. So probability of first draw it is a head is 1.2. Okay, second case also. So the second case also, when we tossing a coin, right, then the second is also 1.2 probability. So probability of the first head is 1.2. So all the probabilities that, okay, let me find the solution here. Let A be the event that first toss will give a head, will appear a head, right, will appear in a head. First toss will give a head. That means probability of A is equal to 1/2. Try to understand this. In first throw it is a head, and let B be the event that in second toss it is a head. So the probability of B is also 1.2. Why? In second throw also. Suppose I am tossing a coin first time, second time, third time, fourth time. In this way, total probabilities are total outcomes are 60 undoubtedly if I take this one case here, but I am taking them separately. This is 1.2, 1.2, all the probabilities are there. And second case, okay, and B, here we are taking and B, and C be the event, and C be the event that third toss gives a head. Third toss also gives a head. That means probability of C is also 1.2, because head or tail, both both probability of both, either head or tail, is 1.2, 1.2. Alright. So here probability of head is also 1.2, probability of tail is also 1.2. This probability is also 1.2. Finally, this is finally, let D be the event that fourth toss gives a head also, right, or gives head again. This is the, so the probability of D is also 1.2. But all these events are independent. We can say all these events are independent here. So the probability of A intersection B intersection C intersection D, here all these four events are independent events. Try to understand this independent event. This occurrence of first is not affecting occurrence of the second. Occurrence of second is not affecting third or second, third and fourth, nothing. So all are independent events. Here all these four events are independent. So by multiplication, this is multiplication theorem we are using here. So by multiplication theorem for independent events, for independent events, okay, so probability of A intersection B intersection C intersection D, all four is equal to probability of A into probability of B into probability of C into probability of D. So all independent events are there. This is equal to 1.2 into 1.2 into 1.2 into 1.2 is equal to 1.16. The probability of getting head, okay, in all the four are heads, is 1.16. Right? So 1.16 is all the four. All the four are heads. That is the probability 1.16. So we have to multiply all the four probabilities. So this is the answer here. 1.16 is the final answer of this, because all are independent events. This is question number 8 we have completed. Now let me take question number 9 here. What is question number 9 say? Let me now check that. 9, 10 and 11, 3 questions are left. Let me first take question number 9 here. What is given? Question number 9 says that an article consists of two parts, A and B. Right? The manufacturing process of each part is such that the probability of defect in A is 0.08, right, and in B is 0.05. All right. What is the probability that the assembled product will not have any defect? So any defect, we can just multiply these two. Independent events are there. Probability of A is not affected. Affected is probability is given. So 1 minus that value will give us probability of not affected. Because a coin is tossed 4 times, what is the probability? Sorry, the 9th one. An article consists of two parts, A and B. Both these two parts, A and B, or manufacturing process of each part is such that the probability of defect in A is this 0.08.